Hello everyone. The next set of problem that we have is the next greatest element. So I'll explain you what does the problem statement mean and how to solve it. So let me explain what do we mean by next greatest element or the greatest next element. So let's say this is particular array is our input, right? And what is the next greatest element in this particular array? We have to find out. So we are expecting a return array which with all the elements that is having the next greatest element of this particular array. Sounds confusing, but I'll explain. So let us say 3 is the first number in this particular array we have. So let's say this is the input array that we have and 3 is the first element. What is the next greatest element for this particular element 3, right? It is 5. Now what we are expecting, we are not expecting the immediate next element. We have to see what is the next greatest element in the entire array, right? For example, for 3, 9 is the next greatest element, right? But 9 may be the greatest element. What is the next greatest element? Next greatest element is still 5, right? So 5 will be stored in this particular location, right? So similarly for 5, next greatest element is 6, right? It is not 9 or 7. Reason is we are looking at next greatest element, not the greatest element in the remaining array. Okay, so for 5, next greatest element is 6, so we have to store 6. Similarly for 2, it is 6 again. Now for 6, it is 7. Now for 2, again it's 7. Now for 7, it is 9. For 1, it is 9 again. For 9, very interesting guys, there are no element that is greatest, that is next to 9, right? So in this particular case we have to store -1. So this is the expectation guys. So basically for each and every element of the array, input array, we have to find what is the next greatest element in the array. We are not looking for the greatest element in the array, we are looking for next greatest element in subsequent locations, right? So we are only moving from left to right guys. So that is also a condition that should be given in the program when asked for, right? So we are only looking for left to right. Now the way to solve this is using stacks, right? So we have to solve it in a reverse way. When I say reverse way, first we have to find in a reverse way. First we'll start with 9. 9, obviously there is no such thing called next greatest element, because on right of this particular array there is nothing, right? For 1, we have to find a way to store what are the next greatest elements in a stack, right? If you use a stack, what will happen? For example, let's say 1, right? We can, if we have stored it in the stack, we can compare it with 1 if it is next greatest element or not, and then put in. So in this position, if we are able to find what are the next greatest elements. So now similarly for 7, if we are able to find a way to store this 1 and 9 in a data structure, then we'll be able to find if it is next greatest or not, right? So I'll write the program, then I'll try to explain how we solved it using the stack. So we need a resultant array. Now I'll store it in another array of similar size. Okay. Now for storing the next greatest elements or the next elements, we are taking stack. So we are taking a stack which is an integer stack. Now what we have to do? We have to move from right to left and see if the element there is an existing element in the stack or not. So it would be very confusing for you if I explain it right now, but I'll write the algorithm and I'll try to explain it later guys. If stack is not empty guys, we have to do something. But before that, I'll find out what if my stack is empty, right? If stack is empty, what I have to do? Result of I equal to -1. So what does this mean guys? If stack is empty, for example, when will the stack is empty? When stack is empty, when there are no elements to the right of that particular index, right? So in that case, what we have to do, we have to just keep -1 here, right? So that is one thing. Now else case, that means stack is not empty, guys. Result of I equal to stack dot peak. I want to push to the stack the element that is coming out of array of I. Okay, now I'll write a logic. When will we pop? If stack is not empty and stack dot peak is less than or equal to array of I. So in this condition, I just have to stack dot pop. Okay, so this is the logic, guys. So yeah, so let me just run it and see what is the output that we're getting. If you see, this matches with this particular output, right? 5667791, right? Now I'll explain how it works. Okay, after the explanation, at the very first time we'll have I equal to 8 and array of I equal to 9. Okay, so this is the first iteration, guys. In the first iteration, stack will obviously be empty, so we'll not get into this if block. It will come to this particular if block, but stack is empty, so this condition will be true, and we'll get into this if block. And if you see, there is only one statement, return of I, which is nothing but result of I, right? Result of 8. So that we will store. What we have to store, guys? -1, right? So I'll replace this resultant array over here. Just for explanation purpose, I have kept it commented this. So I'll resultant, we are storing it in the -1, guys. Okay, so this is the first iteration because stack is empty. But after doing the result operations, we are also pushing the element to the stack, right? What is the array of I? Array of I is this particular 9, right? The last element, because we are iterating from the end of the array, right? So the resultant, the last element in the array is 9, so we'll push that to the stack. Okay, so let's say 9 will be pushed into the stack. Now, as everybody know, stack will be first in, last out, or last in, first out. Okay, we'll move to the next iteration, guys. In the next iteration, we'll have 1 as an element. So that will be at the index of 7, right? Array of I equal to 1. Now this time we are storing some element into the stack, so stack will not be empty. So we'll come to this particular if block, and inside that there is a while conditions. So we'll check stack is not empty, this will be passed, and condition we have stack dot peak less than or equal to array of I. What will be stack dot peak? Stack dot peak will always fetch you the element that is top of the stack. What is the top of the stack? 9, right? Because we have only one element in the stack. Now 9 less than or equal to 1. Condition is not true, right? The condition is not true, and this time we'll come to this particular if block. Again, stack is not empty now, so this condition won't be satisfied. We'll come to this else block, and we are storing a result of 7, right, equal to stack dot peak. What is stack dot peak? 9, right? Yes. Now I have to store 9 in the 7th index of my resultant array. Now after executing this else block, we again are pushing the element, right? So we'll push that 1. Okay, so why? Because I have added in the left is always whenever we push an element into the stack, it will be the first element or it will be the top of the stack, guys. Okay, so that is why I kept 1 in the top of the stack. Now I'll go to the next iteration, which is I equal to 6. Now this time we'll have 7, right? At the 6th index in the input array we have 7, guys. Now stack is not empty again because we have 2 elements in the stack. Now we'll get to this while block, stack.peak. What will happen? Stack.peak will get 1. 1 is less than or equal to 7. What will be operation? This is a true statement, right? Both the statements are true. True and true in an AND is a true, right? So we'll come to this particular statement and we'll pop the element out of the stack, guys. So 1 will be removed from the stack after this operation, right? Now it will again come to this particular if statement. Now if you see, stack is empty or not? No, 9 exists still in the stack, right? So it is not empty and it comes to the else block. Now at the index of 6, what we have to store? Whatever that is there on the top of the stack, we have to store. Now 1 is not there at the top of the stack because we have already popped it out. So we will get 9 and we'll assign that 9 to the resultant array at the index of 6, guys. Now if you see, what is happening as a part of this particular logic is that whenever it encounters, right, if what is at the top of the stack, if it is less than the current element, we are removing it from the stack. That means, for example, let's say 2, right? For example, let's say this particular 2, which is at an index of 5, right? At this point of time, we would have stored 7, 1, 9 into the stack, right? So let's say the next index also 5, right? What is there? 2, right? So by this time we would have pushed again 7 into the stack, guys, okay, because the last operation we would have to push the stack 7. So the next iteration we have I equal to 5 and array of I equal to 2. Now again, array is not empty, sorry, stack is not empty. We'll come into the if condition and while condition, stack is not empty again, and stack.peak. What is stack.peak now? 7. 7 is less than or equal to 2. Condition is failed, so we don't pop. And whenever the condition is failed, right, what we intend to do is, if stack is not empty, we will have to assign that in the resultant array, guys. So stack is not empty and it will come to the else block, and we have not popped 7 out of the array because this condition is not matched. So we will assign this particular 7 in the 5th index. Okay, so we'll do one more iteration, guys. I equal to 4. What is I equal to 4? We have 6. Okay, now again stack is not empty because we have 2 elements, and by this time we will also have to push that particular 2 into the stack, guys. Okay, now we have 6 into the stack. Stack is not empty. So similarly, so we'll validate this condition. Whenever there is a lesser element that encounters, we'll just pop it out. So what will happen here? For example, 2 is less than 6, guys. For example, in this condition, what will happen? We'll compare 2 is less than or equal to 6. Because this condition holds true, we'll remove it from the stack. Now this is a while condition, guys. We have to do this operation until and unless this condition is true, right? So again it will check for the next element also, which is 7, right? But in this case, 7 less than or equal to 6 condition will fail. So it will come out of this block and it will come to this block. Stack is not empty. It will come to else block, and we have to assign array of resultant array of 4 to what is at the top of the stack, right? It is 7, guys. So this is the logic, guys. So whenever you encounter a lesser element than this current element in the input array, we will pop it out from the stack, right? So whenever that exceeds the current value, then only you will put it in the result array. If stack is empty, that means there are no other elements that are greater than the current element, then we'll put -1. So I hope you understood this logic. If you haven't, try to watch it again. So once you understand the logic, it will be quite straightforward, guys. So yeah, as we have run this particular program before, so in the resultant array we are storing all the elements that are the next greatest elements for this particular input array, guys. So that's all for today. Thank you.